Miss O'Connor. Should be able to sign the roll at this time, Miss O'Connor.
Yeah, I've already signed.
Okay. Wait for a couple more people to join in. I opened it a little late. Got any questions about your program?
No, I don't have any.
So you kind of understood the for, the while, and the do while?
Yes, sir.
Okay, all right. There go Durbin. Okay, Mr. Long. Okay, Miss Sue. Okay. We got 5 people that didn't join. Make sure you sign the roll if you haven't already done so, haven't already done so. When we ended class, we pretty much kind of like ended on calculating a running total, all right? And this feature allows you to not overwrite a value in a variable, but actually allow that value to increase or either decrease, depending on what you're doing. Before we get started, anybody have any questions about the programs or anything? Any questions? Okay. All right. So let's read what a running total is a sum of numbers that accumulates with each iteration of a loop. All right. And like I say, it's accumulates. It could increase or it could decrease. You know, it just depends on if you're adding to it or you're taking away from it. All right. The variable used to keep the running total is called an accumulator. Right. So it says many programming tasks require you to calculate a total of a series of numbers. Okay. For example, suppose you want to write a program to calculate a business's total sales for a week. All right. The programmer should read the sales of each day, all right, as input and calculate the total of those numbers. So as they input a number, they calculate it. Then they ask them to input another number. It's calculated. Input another number. It's calculated. So that total keeps on increasing. And what I'll do, I'll write a small program showing you what that does. Okay, but it says the loop that you're using for that, the loop that reads each number, all right, in the series, all right. So that's what you would need, a loop that reads that number each time. And then you need a variable that actually accumulates the total of the numbers as you read them in, all right? So if you look at this program, well, it said the variable that is used to accumulate is called the running total, which we know. So what happens here, we'll set the accumulated value to 0, all right? So say for instance, a person open up a bank account. Okay, they open up a bank account. Then this question is there another number to read? So what happens is, if you read in a number, all right, you read the number in, and then you add it, all right? So like if you had a bank account, if you put $10 in, now your bank account should show 10. Then goes back, it says if there's another number, you read in the number. If say you put another $10, then what? Your bank account should show what? Or should have $20. So that's what they're talking about, accumulated value. So let's look at online GDB. If we go to online GDB and write a program, and just a little small program, IO stream. And everybody's still using that, because I know sometimes, well, no, this is not the class. I was thinking about a header file, but that's my 193 class. All right. But you still have to use the IO stream. So if I open this, so say if I say, okay, int balance, right? I'll say int balance, or I'll say equals, because what happens is, when you use a variable on both sides of the equal sign, now in online GDB, it will not give you an error if it hasn't been defined or declared yet, or given, and I'm not declared, given a value yet. But if you use it in Visual Studio or some other higher compiler, it will give you an error. So you would have to set it to 0, a starting point, okay? So now, if I do something like this, okay, we could do like say while, and we could do the ch is equal y, all right, like we did before, all right, but then I need to go up here and do what? I need to do a char and ch, right, equals y, all right? I could have done a do. Remember, the do will perform it first, and then so that way I didn't have to initialize it. Okay, but say we'll do a while. Okay, and now when we get in this while, well we'll do something like this. Well, let's do a do. It'll be more understanding to you. We'll do a char, and we'll say do. All right. What we're gonna do, all right, and we'll do this, and I'll do this, get down here and do my return 0. All right, so now what we wanna do, we wanna ask the user what? Let's see, enter, cout, enter deposit amount. If I could type. All right. All right. So enter deposit amount, and so I'll say balance should be float, right? Y'all got to case that. It's float. So I'll do cn balance. Well, say amount, not balance. We're going to input an amount. So now we need to what? We need to have what? Amount as a value, a variable that we what? Reading in. And we're going to use balance as the what? Accumulating variable. So we see in amount, but each time we see an amount, we got to add it to the balance. So in order to accumulate a value of a variable, you need to have the variable on both sides of the equal sign. So that should be balance is equal to balance plus amount. All right. So you see what's happening? If the first time with our example of $10, we go through it. We put in 10. It's gonna say 0 because balance is 0 the first time. It's equal to 0 plus 10. So it's gonna solve on the left, on the right, and assign to the left, and it's gonna assign 10 to balance. Then if we say okay, and I have to put my prompter out again. Well, if we for the Y, enter another. Do you want to enter another deposit? If we put Y, then it's gonna say enter deposit, and I need to add that. And it's gonna say, and we input it, and then it's gonna say, if we put 10, it's gonna say 10 is equal to 10 plus. 10 plus 10. So 10 plus 10 gives us 20, and it's gonna overwrite the balance of 10 with 20. So here I have this part. So now once I calculate the balance, now I need to say see out, because what? We got to make sure what? We input a value for whether or not we want to perform this loop again. So see out /T, I don't know how to format it. Enter and or type Y, type Y to enter another. Okay, all right. And then what? Cn, it would be CH, right? And then what? While CH is Y, it'll go back and then another one. And then after we get our finish, I don't want that. After we get we finish inputting, now we could say what? C out, and we could say and all right, so see what happens? This is the loop. This loop will perform, and this should be even. All right, so this should perform as long as I put in the letter Y, the lowercase y. Once I choose no, it'll kick out and tell me what the balance is. So hopefully I got all the errors out. Anybody have any questions about what we just wrote? Okay, any questions? Our variable CH is for our choice. Float amount is the actual amount that we putting in. Balance is our accumulated amount, and we have to set it to equal 0 because of this expression here. Balance equal balance plus amount. So it's on both sides equal. Now, so let's run it. Okay. Oh, well, let me raise this up. So it's a enter deposit amount. So like I say, I'll put 550. All right. Hit enter. All right. Type in another, type Y to type in. I'll put Y. Okay. Enter deposit. I'll say 722. All right. And then we'll say no. So that would be what? 1272. Right. That should. Yeah, 75 is. That should give us 1272. If I say no, anything other than Y, see, your balance is, and it's 1272. Everybody see that? And as long as I put Y and I type in a value, it's going to steady what? Accumulate. Balance will steady or continually accumulate until I put in any other character other than Y. And then it kicks out of the express, out of the loop. Okay, so that's what a running total is. All right. So I think in your program, and let's just look at what we're talking about with your program. Now, this is a do. You could you want them doing a do, one doing a for, one doing a while, do while. In your program, you will not. I repeat, you will not have because I think you're inputting 3 different tests or 3 different amounts. You will not have amount 1, amount 2, and amount 3. It'll be similar to this. You're gonna have one amount or one CN for the values that you're inputting, but they will be in a loop. And as you go through that loop, you're taking that value and you're accumulating it. Now, once you accumulated that value, then you can what? And then this would be if you're finding in your program, you're finding the average. You know the count for the loop is 3. So that could be a constant value. All right. And then you would take whatever that balance is and divide by 3. Okay. But you should have only one particular variable that's reading in the data. All right. Doing that CN amount, not CN amount 1, CN amount enter, CN enter amount 2, enter amount 3. No, 1 CN and prompt to input that value, and your loop will continue for 3 repetitions. All right. Questions? Everybody understand that? Because anything else will be wrong. All right. You're not actually using a loop. Okay. Now, some people I think started trying to use arrays. I don't want arrays. Like I say, that's a little advanced. We'll get to that at the end of the next class, the 193 class. We'll start with arrays. But I want you to be able to use the loop, be able to have that one input statement here, and then accumulate it, and then calculate your average. Okay. Questions? All right. Anybody? Okay. So that's what that does. It actually allows that value to be accumulated. So look at this. How many times this loop is for performing? From 1 to 5. So okay, so it's gonna perform 5 times. All right, 1, 2, 3, 4, 5. It didn't say less than 5, all the way to 5. And each time you input a number. So they're gonna input a 5. Well, it could be the same number, but you're doing it 5 times. Each time you input a number, total equal total plus number. Second time, total equal total plus number. Third time, total equal total plus number. Fourth time, total equal total plus number. Fifth time, total equal total plus number. And then you exit it out and you print out the total. Okay, so that's pseudocode of how to write or manipulate or do the accumulation of a variable. All right. Any questions? All right. And all it's saying is this is the key statement that will allow you to accumulate that variable being on both sides of the equal sign. Okay. All right. And this is just the flow chart. Okay. Like I say, if you're running the issues, you always could look at these examples to see exactly what and how to do, look at your program. Some things you might have to eliminate, some things you might have to change, but it's the theory of it and the process is the same. Because look, count less than equal to 5. Yours is what? Your program saying what? 3. Okay, your loop is performing 3 times. This is set to where count is 0. All right. Well, count is set to 1, and it's doing less than or equal to 5. So that's one difference. All right. Enter a number, calculate the total. All right. Then the count increment. So that is correct. But then when your program gets out the loop, you're not printing out total. You have to calculate an average and print out the average. Okay. So it's set up similar, but like I said, you're gonna have to know exactly what's going on to write your program. Any questions? Questions? All right. So now a sentinel value. When you have loops, sometimes programmers, what they'll do is they'll have a sentinel value, all right, or even with a data file, you have a sentinel value to mark the end, all right, or mark that you want to end a process in a loop. And what that does is, like, say what happens, we have char here. Where is it? We have char here, so we can only enter one value. But if I change this to well, I could leave it as char. All right. So we put in all this and and we could allow this thing to perform. All right. Do while choice not equal and if it was a number, I'll do string. Well, let's make it 0. So in this program, pretty much 0 is our sentinel value. So it's like we would this thing would act. Well, this is kind of deceiving. Type Y, to exit, but we can take this out. All right. Well, no, we have to leave this in. Well, we have to add not type Y. Take this out. Just say well, I'll just say exit. All right. Do you want to exit? All right. So we know that what to exit is what to type what 0 a 0. So when we run it, this thing will pretty much if I could. It would pretty much perform as long as we don't type what a 0. So we could just continue what it's doing. All right. But now it say 0. So see, 0 is the value that's triggering it to exit out. All right. So it says, consider the following scenario. You're designing a program that will use a loop to process a long list of values. All right. So at the time you're designing a program, you do not know the number of values that will be in the list. All right. In fact, the number of values in the list could be different each time the program is executed. Okay. So what happens is the best way to do this is say, okay, my last number that I'm going to read in, I'm going to read in 99999. So, and like I say, hopefully you're going to find a value that is not being read in. And like I say, normally a 99999 or a series of nines, you're pretty much safe. And so when the system, you let it loop until it reads 99999, and when it reads the 99999, it exits out. All right. So it says here, it says, here are some techniques that you have seen already in the chapter, along with the disadvantages of using them when processing a long list of values. Okay. Simply ask the user at the end of each loop iteration whether there's another value to process. And that's normally what we be doing, right? If the list of values is long, however, asking this question over and over can be tedious, all right? It says also, when you ask the user at the beginning of the program how many times the list, how many items are listed in or contained in the listing, all right? So like a lot of times, if you like when we did I think it was this class or another, where we did the squaring of a number, where we multiplied the number by itself. How many of them do you want to do? If I say 5, it'll do 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and then exit. So I can say that sentinel value was that 5, okay? 5 was the number, it's 5 times, and then when it's gonna kick out at 5. So when processing a long list of values with the loop, perhaps it is better it's a better technique. Well, a better technique is to use a sentinel. All right. A sentinel is a special value that marks the end of a list of items, and you're gonna appreciate that when you start dealing with data files. All right. Sometimes people write data files read data files where they say, okay, read to end of file marker, which is good. And sometimes people might say, okay, what I'm gonna do, I'm gonna put a sentinel value for one of the read variables I'm reading in, and when it checks that, it kicks out. Okay, so it just depends on your programming style. Okay, and remember what I said: a sentinel value must be unique enough that it will not be mistaken as the regular value in the list. Because if I'm reading numbers and I set my sentinel value to 99, which is 99, then I cannot read in, or I cannot want to read in a 99 as a valid number, because as soon as it hit that 99 is going to trigger it and tell it to kick out. All right. So a sentinel value has to be unique from the values that you're reading in. Okay. All right. And look, they say while not equals not equal zero. Remember we did while the choice was not equal not equal zero. We continued until then and kicked out, and that's what they did in this program. See here, while lot number not equal zero. So and what obviously if you had a lot, and I think this is dealing with a parking lot. If you had a parking lot, normally you would not have a lot space or a lot number that would be what? Zero. You would start one and above, right? So zero would be the trigger to kick on out and whatnot. So it got to be unique, all right? Got to be unique, all right? All right, questions. And so look, they declare their variables, all right? Display enter 0 to n, all right? So, and then what? Input a lot number. So they input, say maybe 55, gave a person and they gave a person their ticket, then calculated their taxes, whatever. Okay, then what? Enter the lot number for next property. Okay, so if there's this is dealing with actual property, not car lots, car space. But even though in a lot number, if you put 0, that means what? Oh, we're gonna kick on out. All right, input the number. All right, if it's 0, where it is, where is it? All right, going back here. If it's 0, you're exiting out. All right, if it's not, you're going all the way back here, checking it's not 0. You're calling what? This function that calculate their property tax. Okay, so that's dealing with property tax. All right. Now, nested loops. Nested loops are fun, but they can be confusing. All right. Nested loops are sometimes very confusing. But once you get the hang of them, man, you got it. A loop that is inside another loop is called a nested loop. All right. So it says a nested loop is inside another loop. All right. A clock is a good example of something that works like a nested loop. The second hand, minute hand, and the hour hand all spin around the face of the clock. The hour hand, however, only takes what? One revolution every 12 hours, 12 every 12 of the minute hand revolutions. And it takes 60 revolutions of the second hand for the minute hand to take one revolution. So what's happening is you have a loop within a loop. So as the second hand move, as it get back to the 59 and back to the 0, the minute hand moves. And then as the minute hand moves, as it goes 60 times around, the hour hand moves. But let's look at this, all right? And then they give you examples, but I'm gonna show you an example. Look at this. If I have a loop, I'm gonna take all this out and I'm gonna just use a number loop this time, all right? So I'm gonna use a number loop, the for loop, for int I'll say x equals 0, right? X less than 5. So how many times this loop will perform, class? X plus plus. So you're going 0, 1, 2, 3, 4, kicking out at 5. So this loop will perform 5 times, right? Now, if I do this for int y equals 0, y less than 10, well, I'll do 2. 2, so you can actually see it. Y plus plus, all right? Then I'll do something like this. Now I'm asked the question, how many times will BRCC be printed? How many? We got an outer loop of 5, and we got an inner loop of 2. And inside that inner loop, we print out BRCC. So this is what happens. X starts at 0. All right. Well, let me see if I could go to the change my view right quick and write on the board. Let's see. Where am I? Where's the board? All right. All right. So X starts at 0. Right. I'm gonna try to write 0. Then it falls into the loop. Y starts at what? 0. All right. So this is X. And this is Y. If I could try. All right. So X is 0. Y starts at 0. Y go to 1. Then Y gets to 2. It kicks back out, but now I'm back in the outer loop. What happens? X become what? 1. Y becomes what again? 0. Then Y becomes 1. Then kicks out that loop. X becomes 2. All right? Then Y becomes what? 0 again. Then Y becomes 1. It kicks out the loop. Then X becomes 3. You see the pattern? Y becomes 0. Y becomes 1. Kicks out the loop. And I'm on the outer loop. X becomes 4. Y becomes 0. X becomes 1. See, a Y is always starting over. Kick out the loop. We get to 5. And then what? We kick out of that loop. So how many times did the Y loop iterate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times. And the easiest way to do that is when you're looking at it, it's simply, I need to go back and share the screen again. So the easiest way to look at it is to say 2 5 times. So 2 times 5 is what? 10. So that's how many times it will print. So if I run this, hopefully I got all the errors out. See here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? That's a loop within a loop, which is a nested loop. All right? Everybody see that? All right? Now, many times when you get to the upper levels and you're dealing with arrays, and especially two-dimensional arrays, you'll be dealing with nested loops to try to manipulate. And that's pretty much the best way to deal with a two-dimensional array, which are nested loops. Because an array, a two-dimensional array, is like a table, or like, you know how a spreadsheet, you have columns and rows. All right, same thing with a two-dimensional array. You have, well, then I say column first. Normally in computer science, you say the row first and then the column. right? So if I want to look at a number in an array, in a two-dimensional array or position, I would say the row number first, followed by the column number. And it always starts at 0. So it doesn't start at 1, it starts at 0. So if I have a 3 by 3 two-dimensional array, it would be 0, 1, 2 for the rows, and then the 0, 1, 2 for the columns. So I would have a 0, 0 position, which is the very first position, and the 2, 2 position, which is the very last position. Okay, so but that's later on in your computer career. Don't worry about that. But nested loops, and like I say, if I change this to 12, that's what 12 5 times, which is what 60. All right. So see how you can actually manipulate your nested loops to perform X number of times if you need them to or whatnot. All right. So and give you an example with this nested loop, and I'm not going to give you this program, but if I told you to write a program using nested loops that will read in or process 5 different students who've taken 10, well, not 10, 5 different students who've taken 3 tests and calculate their average, right? But I want you to input the first student, then input the 3 scores, calculate their average. And then input the second student, input the 3 scores, calculate the average. Input the third student, input the 3 scores, calculate their average. You would, and until you get to the 4th one, and then you would do it somewhat similar to this, all right? In a sense, and I'll just modify this a little bit. I'll say, I'll change this to like maybe 3 students with 2, well, I'll say 2 students. I'll do it. 2 students with 3 test scores. All right. So now I need to do a string. All right. And hopefully I won't have to do ignore. All right. I'll do upon include string. Okay. So I could do string name. All right. And then I could do int. Well, I'll do int for the score. Int score. And then I'll do int average. Well, I could do int average. All right, just do int average. So now, and then I'll just say, yeah, and well, I'll say total. Because remember, I got to keep a running total. So in here, I would do what? Cout, enter. And I'm not going to do the / for the enter student name. All right. CN what? I'm in get line. CN name. All right. So that's going to allow me to input the name. But notice where I'm inputting the name at, though, class. I'm inputting the name while I'm in what? That outer loop. Because I only want to input how many names? 2 names, right? So the first time, the first name I'm going to input. Then I'm going to fall in here for 3 times. And now I'm going to input the test scores, okay? So I'll do something. If I could take this up. Okay, I'll do cout enter test score. Now, it's some fancy trick I could use to tell it what test score. I could do something like enter test score and then space, and I could and I'll say number, and I could do something like this, y plus plus, well, plus plus y. So what that, So that's going to allow what? When y is 0, it's going to output enter test score number 1, but we really at 0. Then what? Enter test score, when it's 1, is going to output 2. But I'm saying that's just little tricks you can do to kind of keep track of what's going on in your program. All right. And then we do a CN score. All right. Now, while we're in here, we have to say what? Total is equal to total plus score. Because if we do not accumulate the total, we just going to get that very last score. And if we take that last score and divide by 3, we won't get the right average. All right? Or it's likely that we won't get the right average. All right. So now, this inner loop that's going to actually input the scores. So now, once I fall out of the loop, I'm back in the outer loop. Before I return back, now I need to calculate my average. So here I could say what? Average is equal to total divided by the 3, because I know it's 3 test scores. I could have used a setup, a constant variable or whatnot. And then I could say cout name, name, because you want to put out the name, all right? And okay, and then average, and then so now I think I got that inline right. Yeah. All right. So now it's going to do that first time for the first student. Then what? X becomes 1 in another student name. All right. Then for X, Y equals 0, Y less than 3, it's going to do this for another, for three times for 3 scores, getting a total. And then once we kick out, we're taking the total divided by 3, getting the average, and then we print out the name and the average. And then we're going back to the for is 0 less than 2, yes. And then we what? Not 0, 1 less than 2, because we got an increment, and then it's continued. So let's run this to see what happens. All right. Well, with okay, let's see. I can't pull this back up. With I need to get to okay. Here we go. All right. So look, enter student name. I could have. I just like to have the spaces there. That's not right. Let me end this. Stop this. All right, colon. All right. So now run it again. All right, student name. Say I say Bill. All right. Hit enter. Look. Enter test score, and look, that 1 is coming from this plus Y. All right, and I don't know. This we didn't talk. I think we talked a little about this when we was in class. The pre and post of plus and minus. So this will actually add 1 to Y on this line. So Y is 0, it's going to be 1. When Y is 1, it's going to print out 2. When Y is 2, it's going to print out 3. So first score, then I didn't even put a space. So let's say we'll put 100. All right. Second score, we put 90. Whoa, why it went to 3? I messed up because I actually added this to this. I actually added. I don't want to add. I don't want to add. I don't want to add. Let me stop this. Now what I'm gonna do, I'm gonna negate it. Okay, Y minus. Just for the time being, I'm gonna just negate it. Let's run it. Okay. All right. So we run it and we say Bob. And number 1, we'll say 100. Test 2, we'll say 90. Test 3, we'll say 100 again. Okay, Bob, that's a semicolon. Average 96. But look what it's, see, I need to do a send dot ignore. I told you, I knew that, I knew that, I knew that, I knew that. Man. What happens is information is still stuck in the buffer. I think this is what I needed. Run it. 100, 90, 100. Right. So see, what happens, this command clears the buffer because when I go from CN of a string and well, I did the get line, but then I did a CN of a number. When I do a CN of a number, it only grabs just the numeric part and it leaves the that return key, the return mark that in the buffer, in the keyboard buffer. So when it goes back to read in a character, that keyboard buffer, whatever's in the keyboard buffer, such as that return key, it reads that and automatically puts that. So what you have to do is use that cn.ignore to say, okay, before I go back and input values for a string, because I've just inputted values for a number, clear my buffer, my keyboard buffer, so I'm starting anew. All right. So this is the second student. All right. And so I'll put in whoever, Mary. All right. And then I'll say test score 1, say 70, 100, and 100. And so see, wait a minute. That average is not right. Unless I type something. It should be what, 86. But I don't know why I put this 1 here. I don't know if I typed that or what. Oh, yes, it did it right. I'm gonna show you what I didn't do. But then we'll get off of it. What happens is the first time through this loop, total was what? 0, correct? Now, I calculated the average for the first student. Total still is what? It was 100, 99, 190, and 100. The second time through, I didn't set total back to what? 0. So total was started, and I didn't start at 0. Total started at 290. So really, not what I want to do is, after I get my total, I want to set my total to 0. Well, not in here. Yeah, it's global. Well, so I'm setting the total to 0. So now when I calculate the next student's grades, it's going to start with total being 0, just like a bank balance starting at 0 for the next person. All right, so that's it. But basically, that's what loops within a loop, nested loops are, and how they work. Anybody have any questions? I know this is kind of advanced, but I just wanted to give you a kind of life experience or life scenario of how and why you would use nested loops. Because sometimes you're trying to do two things or collect data from two separate entities, but you need to loop one a certain amount of time and the other loop a certain amount of times, but you want to do it in a nested way. Because if I was reading data from a data file, I would have student name, score, 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 student name, score, score, score. So I would have to read what? The name, and then fall in the loop and read the 3 scores. Then go out the loop, come back in, read the next record, the name, and then the 3 scores. I can't say, okay, I got a file and it got name, score, name, score, score, score. You know, files don't come like that. File comes like records in a sense where all the information on that one row belongs to that one person. All right. So you got to keep that in mind. All right. Otherwise, data could be confusing. All right. So now we back into our notes, and all this showing us is what? a flow chart where we had set hours to 0. If hours is less than or equal to 23, all right, 0 to 23 is 24, all right. If it's true, then we're doing what? Setting minutes to 0. And if minutes is less than or equal to 59, then we setting seconds to 0. So see how it have a nested loop. The minutes, well, the seconds is within the hours, is within the, seconds is within the minutes, is within the hours loop. All right. So you got 3 levels, okay, 3 different loops. All right. So what happens? You perform 59 seconds. Once you get to greater than 59, all right, then it kicks on out and go back to the minutes. And when minutes get greater than 59, it kicks out and it goes back to hours. So now there's 1 hour. All right. So then that's how basically what the example they was trying to show you. All right. Okay. Now, okay, this is the end of this chapter. Anybody got any questions? I know the nested loops, I went over some other stuff, but any questions? Questions? All right. So let me do this. Let me post the test now because I probably forget if I don't. All right. So what I'll do, I'll post the test and then let's see, no, I never did the request. All right. I'll do the quiz too. I'll post the quiz here. And the test will be open from today until Tuesday of next week. All right. Everybody got that? Before class. All right. So 2 chances, no password required. And today is the 14th, so the 21st at 1 o'clock. All right, so it'll be available up until 1 o'clock on the 21st. All right. So that's the quiz though here. And then I'll do the test. All right. The quiz, like I said, is just some selected questions from the chapter. So you'll probably see those same questions on the test. All right. Okay. And so a test. And my programs do what? Tomorrow, right?
Tonight at midnight.
Okay. I thought I saw 15. Oh, no. You know what I did? I increased the date because Mr. Gaddis, he said, Miss Messer, I had tests, I had whatever, I'm kind of swamped. Would it be possible for you to extend the date to Thursday? So I said, well, I'll give you 1 day. You know, so I just give y'all an extra day. But don't wait till the last minute, class. All right, things happen, all right? Don't wait till the last minute. All right? So 1 o'clock p.m. All right. All right. So 1 o'clock p.m. Okay. Save and publish. So now the test has been posted. Okay, so that's posted. Now, I'll tell you what, though, I'll do this on this test. I'll give you okay, 60 minutes. It ain't gonna take you 60 minutes, but I'll give you 60 minutes to take the test. All right. So now that's done. So the next chapter, functions. All right. We've kind of dealt with functions in chapter 3, right? Somewhat. All right. But we'll go ahead on and kind of start with functions, and we'll work on with functions on next class period too. But we're gonna go over functions. And if you look at it, we kind of looked at it where we did functions where they didn't have any arguments. Then we showed where they had functions where they had arguments. And then we showed functions where, and I think we just went on and did passing by reference. All right, we did that also. All right, but we'll look at that again. All right, okay. And also we did what? Returning a value, okay? Returning a value to a function, right? So basically that's what this chapter is on. Except we had some other information on functions. Yep, see returning a value, no matter what it is. What mathematical functions. We could look at that, but like I say, once you load the CMath or the math.h, then you have what other functions, square root, sine, cosine, tangent, and all those things that you can use. See, these are some of the round. All those functions are available, and you can look online and find many other functions that are available uh, in for the math, CMath. Look, the dollar sign and then whatnot, formatting the function. All right, so let's see. The formatting function for numbers. So let's look at um, functions, all right? And what I'll do, you can read the book, but remember, we'll go and we'll look at functions. Now, remember, I'll take all this out. Well, no, I'll leave this because I could use this. All right. So say a function. There's 3 steps in creating a function. All right. One is its prototype, and normally that's when you actually defining it, declaring it, telling okay what your function is. So if I do something like, well, I would have to move this because remember we talked about the scope of a variable. And we're talking about global and local variables. What happens is I cannot use variables in another function if it's not globally declared, okay? I would have to pass that value of that variable to that function, okay? Well, let's do that. I'll do it after we do that. So we declared these variables: string name, int score, and total equals 0, int average. Those are declared global. They're not in any function. They're not in the main function, and I don't have any other function. If I wanted a function, I would have to say void or int or bool or char, all right, or double, all right? If I was writing a function, if I use int, char, or any data type, that means will be passing a value of that data type back to that calling function, all right? Now, if I use void, all right, that means I'm just calling the function, I'm performing it, and I'm gonna just return back to the calling function. All right. So void, the name, and then the name of the function. Now, the name of the function, you're just gonna have to follow the same naming scheme as you use for variables. Remember? Now, some programmers, they'll come up with a programming style as to okay, all of my functions, I will have them capitalized. Or all my functions, I'll capitalize the first letter of that function, or I'll capitalize the function name, or I'll capitalize the first letter of each word of that function, or the first and last letter of that function, or I'll use camel case. But whatever your style is, all right? So I can create something for this called student, remember, average. Because it has to be what? One word, right? Cannot begin with a number and no special characters. So my function that I'm declaring is student average, all right? Or I could have called it calc average. Whatever I feel that I can relate with, I say calc average. But it's still one word, doesn't begin with a number, and no special characters, okay? So we call it calc average. That's one thing that you have to, one thing, like say, one of the processes that you have to follow. Another one is you have to call the function, all right? So we get in our main, to call a function, you just type the function name, calc average. And we're not passing any arguments, so we just put open close parentheses. Now, what I want to say about this. Calc average. Right, okay, calc average. Now, this information here needs to, which is our calculation for our averages and the name. I need to cut this, all right? And then I need to define my function. So when I define my function, I need to basically look at my definition, my declaration. It says void. So there's no int, no char or anything. So I'm not returning any value. The name of the function, calc average, all right, and there's no argument. But at this point, I will not put a semicolon at the end because I'm defining my function. Just like you don't put a semicolon after int main, because what? This is a function, int main, no arguments, and then I got open curly brace, close curly brace, all right? Void calc average, open open parentheses, close, no semicolon, and then my curly braces. And all I need to do now is paste my information for my function in the function definition, or the definition in the function. So all that information that I had here, such as, for my for loop, is now what? It's inside of this particular function, all right? So the program should run exactly the same, but look what happened here. I kind of cleaned up my main function in that what? It says int main, and then it says calc average. What is calc average doing? At this point, or if you're looking at a program, we don't know what it's doing, but we know it's what? It's going to that function and performing some kind of operation. And then your program does what after it called calc average? It doing return 0 to main and end it. All right. So see, I kind of simplified the what the program is, the process of it. Because if you had multiple functions that's being called from your main, it simplifies your main so you can pretty much see somewhat of what's going on without seeing the very nitty gritty of what's happening. You might see something like retrieve student name as a function, search for student name as a function, sort student names as a function. So in that main function, you're seeing that it's retrieving the name, searching for the name, sorting the name. How it's doing it, you don't know. But if you wanted to know, all you have to do is what? Go to the function and see what it actually is defined to do. So let's run this program. Well, first of all, what we said, the steps, number one, you got to declare the function, all right? It's prototype, all right? The function prototype. So this is the function prototype. All right. Then, I'll say the function definition. I'll just go with it next. And the function definition is just what is the program, what is the function to be doing? What are you defining the function to do? And then what? If I have a function in my program, I should be able to what? Call it. And this is my function call. So this is why I'm actually calling the function to go ahead on and perform what's in that function. All right. So those are the three important stages in creating and using a function. All right. But notice, no arguments, no arguments, no arguments. Void in my function definition, void. All right. I don't have anything here because this is the call. So let's run this program. Okay, we run it. Hopefully, see here, enter student's name. So what happens? It declared student name to be what? Global. So I could use it in any function. It declared score and total to be global, average to be global. So I can use them anywhere in the program and I won't get any errors. So now it says what? Okay, in the main, it went to the main and it says what? Oh, call calc average. So where's calc average? Out here is defined and it says for int x equals 0, x less than 2, x plus plus, then what? Enter student's name. All right, so then it asks you to enter the student name. I want to change that, but okay. So now, like I said, doing the exact same thing. So like I say, I'll enter Tim. Okay, score 1, 11, 22, and 83. Average of 38. Say what else? Say Alice, and we'll say 100, 300. Oh, I'll put 300. All right, that's an average of 140. And like I say, we could have controlled that 300 where we could have had an if score is greater than 0 and less than 100. Greater than equal to 0 and less than equal to 100. Remember those if statements. So that's what you get. So see how your program over time can get larger and larger and larger depending on how much you want to validate, how much you want to prompt the users to understand what's going on. So and even like I say, control the integrity of your input. All right. So after the second one, it outputted the average and kicked out. All right. So the program what? Executed the same way, but what? It's kind of like the main function is not cluttered with all kind of if, else, well, not if, else, but for a nested for loop or whatnot. Now, you say, well, Mrs. Lester, well, what's the beauty of having functions? Check this out. Watch this. If I do this, well, not say, I'll say what? Okay. All right. Now, but I need to go up here and do what? Now, so the beauty of this is now I have all this right here rather than, and I want to perform it like when this is not really reality because what? This for loop performs 2 students at a time. So looking at this, I got this while choice is equal to Y. I got it set up declared as Y up here. All right. Then it says perform calc average. Calc average is going to allow me to input a student, calculate the average. Input a second student, calculate the average. But then it returns back to this main function, and it's going to say enter Y to enter, well, I said enter process. To enter 2 more students, or to process 2 more students. To process 2 more students, all right? So if I put in Y, then it goes back up here, it's Y, then it calls that function again. So you see how it kind of took a lot of information out of my main function where I'm not dealing with all those curly braces and whatever and knowing exactly where, what, how. I got it all defined. I got it all in a function, and I can call it as many times as I want. I could put it in this loop and have it loop as many times as I want so that I don't have to see all that and know where to exactly put curly braces. Because here I got what, these two, but then what? If I was here, I'd have this, and this, and then that would be in a different level. So it's like, your levels would be deeper, and you'd have more open curly braces to have to try to manage. All right. So let's run this and see what happens. All right. So we run it. I got an error. Oh, semicolon. Me and them semicolon. All right. So that semicolon there. I still didn't change this. All right. So now we run it. All right. So watch what happens after I put 2. So I'll put in Billy. I didn't change that. 100. Well, 100, 188, and say 95. They got a 94 average. Then I'll say Timmy. All right. Say 100, 88, and 85. But look what happens. All right. You got his average, but look. Enter Y to process 2 more students. So what happened? After it what? After it performed this last name, and then it completed this this loop here, then it kicked out and went to this curly brace. So it kicked out of this function, and it went back here. When it comes back to the program, it goes to the next executable line, which is enter Y to process 2 more students. All right, which is what we have here. All right, so if I put Y, then now, wait a minute. Oh yeah, so it looked like I might have to do that cn.ignore again. All right, because of this. See, I put the Y, but see, it skipped the student. So now, remember that error I had? So all I need to do is oh man, I need to stop this. All right, but that's something you don't have to worry about, because we deal with that in the next level. cn.ignore. All right, so we run it again. Let's run it, and I'll put in Bill. I didn't fix that. 90. Okay, 93. So 99. Well, oh, that's the name. 99, 99 average. I'll put Y. Okay. So see here, it took that, cleared that buffer, and now I can put in another name. All right, I'll say Sue. Okay, 185 and 93. All right, I'll say May, say 100, 67 and 97. See? And another student. If I'll say Y, it's going to continue. If I say anything other than Y, it exits out. All right? So, that's using a function with global variables. All right? I'm not passing anything because everything is what? Global. All right? But now, if I wanted to, all right, I have in here, I have total, okay, and I have score and average, right? So I'd have to do another program, because what happens is I want to read something and pass it and process it. So yeah, I'll save this one, and I could post this if y'all want to see it. All right, I could save it. What does that say? Okay, save here. Okay. All right. So now, anybody have any questions so far? So what I'm gonna do, I'll take this out. Now, all right, so here we have, I got a name, I got a score, a total, and average. All right, so if in here I'll take this information, I can delete this, I don't need that. I'll take this information and I'll cut it and I'll paste it inside the main. When I do that, class, I should have left the other one. When I do that, now I'm making my variables local to what? The main function. Where they can be used? Only in the main function. If I wanted to use the values of these variables in calc average function, I would have to pass the values pass by value or by reference into these functions. So what I can do is I could do something like, and I took all that out. I should have kept. So if I did see out enter name, and I'll say cn dot, get line, is that a little get line? Yeah. Then name. All right. So now I'm gonna get the name, whatever the name is. If it got spaces, no problem. And then I'll do something like get average. I'll just do the average. Just see out all right. So I'm not calculating, I'm just getting it. All right. CN. All right. So I'll do it in a student's name and a student average. Now, I can do whatever I want with student name and student average in the main function because they are what? They are declared in the main function. All right. Now, if I wanted to use the value of name and average in calc function, I would have to pass them. All right. So now I would have to call my function calc average, and then I would have to do name and average. So that's the value. But if I look at this function or the call function, and I look at my function prototype, my prototype says, what arguments am I passing? It says nothing. My prototype should, in the argument list, should tell me what's the data types of the variables that I am passing when I call this function. So name is of what data type? String. And average is of what data type? Int. So you understand? So now I have void calc average, and I'm passing a string and an int when I call my function. So look, calc average, name average, string int. All right. Now, when I look at my prototype and I look at my function definition or the header of my function definition, it's showing that I'm not I don't have any arguments being received, but I know I'm gonna be receiving a what? String, and I'm gonna be receiving int. But I have to, being that I'm in a new scope, give my values that I'm passing a variable name. One thing about it is I can give it the same name as in the other function because I'm in a what? Different scope. So I could say string name. So now I'm declaring name to be a string to be used in calc average. And now I'm declaring average, all right, to be of int and be used in my calc average function. So now in here, I can do this. Well, I got 3. Oh, I didn't take that out. All right. Now what I can do in here, I know what those values are. I can do cout and then I can say name. And average. All right. All right, average. All right. All right, class. I know it's getting close to the end of class, but let me run this and let you see what happens. So what's going to happen is my variable is going to be declared inside the main. I'm going to input my values for my variables. Then I'm going to call the calc average function, all right? And when I call it, I'm passing the value of name and the value of average to this function. We'll call calc average. And now I'm passing name in from main to name in calc average. I'm passing average from name to average in calc average. And then I'm printing out those values. So when I run it, oh, got an error. It said before return 0, probably a semicolon. Return 0. Yep. And I call a function, I have to have a semicolon. Calling it. Run it. What's this? Oh, average. Okay, come down here. This. Oh, uppercase. All right. Remember, uppercase and lowercase are unique. All right. So in our name. So I'll say Anthony. All right. An average, say 89. Hit enter. Look what happened. Name is Anthony. Average is 89. But I'm going to show you something, and then we're going to go. I could take the name, all right? I'm going to just take this variable. I'm going to cut it, and I'm going to, what I want to do? I don't want it global. Well, let me undo that. Control Z. All right. So I got name. How I want to do that? And it's path. And it's local. Okay, I'll do this. I'll say, okay, name. I'll show you this way. I can rename the variables in here. AVG. All right. So now, and I need to change something down here, but I'm going to show you. I'm passing name that I input from main, all right, to NM in calc average. I'm passing average in from main to AVG in calc average. But what I need to do here, because now I'm saying what? My variable, my string variable is called NM in calc average. My int variable is called AVG. So I need to make that NM because calc average does not know what name is because I said I'm passing name into NM. Calc average does not know what average is because I said what? I'm passing the value of average into AVG. So this knows what AVG is. The value of average is passed to AVG. Let's run this without changing average. It will not know what it is. Watch, I'm gonna get an error. See, average was not declared in this scope. It's declared here, but not here. I said I wanted to put average into AVG. So I need to change this to AVG. And all of a sudden now, the program will work. See? So now I'll put a name. So I'll put Mary again, and then I'll say average, a 98. I thought I hit enter. Yeah, and see, it prints. So you can do that. So next class period, we'll look at look at functions a little bit more. And like I say, I don't know if I'll give you a program. I gave you the program in the other one, but we can discuss, and I can show you different ways of how functions are used. Now, you got to remember too, class, the date is the 14th. Next week is the 21st. All right, so you're taking your test on chapter 5. We'll probably we'll meet on the 16th, and we'll probably have a test on the 21st. We're dealing with the functions. But the next week, I'll post the pre-test, the final practice, all right, and I'll make available the tests and the quizzes that people that people want to take. Okay, so I'll do that on the 28th. But you got to remind me. I'll do it though. I normally will do it though. But well, no, I'll make them available probably before that on the 27th, being that somewhat online on the 26th or 27th, and you'll have that week to complete them. All right. Okay. So anybody with any questions? But we can go over this some more on next class period. All right. Any questions? All right. If not, okay, I'll see you on next class period. Do my assignments. Take your tests. All right. Make sure that respondents work for you and whatnot. Okay. And I'll see you on next class period. Have a good one. All right. Well, here we go.